Hello, welcome back. Now next in the next step we want to code a GPT kind of language model from scratch, which would be a very small scale GPT where we would have decoder only part of the transformer models as was described in the attention is all you need paper, and we'll try to do that at the character level modeling. So um, characters will be our tokens in the data set, and we'll take a context or a block size of characters, and we'll try to predict the next character based on that block size, let's say 8 characters as input. And we'll be doing this with the help of transformer based decoder models. So let's start. Okay, so this is a input file, which is the text from Shakespeare's books. So this is what the data looks like. It is just a plain text written by, say, Shakespeare. We are going to take this, read this as input, and then we are going to break it into small tokens, which would be a character. So F would be a token, I would be a token, etc. So this is kind of similar to what we have been doing in our character level language modeling from bigram using neural networks and wavenet kind of architectures. So that part would be same. Just the first difference you will see is when we'll prepare the data and data loaders. So let's start with it. I have read the input.txt file into Shakespeare variable. So let's try to print first 200 length of the Shakespeare text. So this is what it looks like. First citizen before we proceed any further and so on. So this is the text. Now let's to start with prepare a vocab. Vocab would be, so this is, these parts are have been well done into the previous videos where we explain the bigram or bigram language modeling using neural networks, wavenets, etc. So this is what it looks like. So yeah, this is what it looks like. This is the vocabulary from our data, and vocab size is 65. Now we'll have to make a encode and decode method to, so basically let's create mappings first. S2I is uh, dictionary encapsulation of string to character for I ch in enumerate of Shakespeare S2I. So this is what it would look like. Sorry, not in this, in this. So this is what S2I would look like, and I2S would be ICH for CHI in S2I dot items. Yeah, so the reverse mapping from integer to characters. Okay, now we have these. Let's make encode method, encode characters to strings. list of characters to list of integers basically. So what we do is lambda of s is to I of ch is to I of ch. So code of hello would be something like 1 2 3 4 5. So 5 characters. So this is working fine. There would be another method, decode list of ends to list of characters. Decode equals to lambda of list dot join list of characters. So it would be I to S of so basically here I'm encoding hello using this encode method, encode function, and using so this should give input as a list of these integers to decode, and so output of the decode should be hello as is. Let's see. Good. Yeah, so it's working fine. So let's this out. We have our encode and decode method ready. Let's say we now let's encode entire text that we have. Um, Shakespeare. How do we check? Length of data equals to length of Shakespeare. This should be true. Cool. So yeah, we have encoded our data and our text. So this is how it looks like basically. Let's say if we print this, might not be easy. Okay, let's say we print 100 characters in data or 10 characters in data, and then we also print um, Shakespeare first 10 characters. So these this text is converted into these list of integers. That's what is happening basically using encode and decode function. Now let's prepare input that should go to the network. So what input would look like is a window of characters converted into integers that would go into the transformer network that we are going to make GPT model. So let's say the length of that window would be, we can start to keep it as 4. So 4 characters would go simultaneously into the network and they will output the 5th character as output. So here uh, let's take this as only dimension, batch dimension right now. We're not going into the batches which would use the parallelization feature of GPUs for now. We'll just start with block size, the time dimension. So our input should look like uh, a vector of 4 length. So basically something like this. Let's say I copy it from here. 1 2 3 4. Right. So something like this. So it would be a input and output would be the next character, 58. 58. So when we say that we have a context window of size 4, it doesn't mean that every input that goes into the network, we want them to be of size 4. We want them to be of different sizes. So first is we want them to be of size as low as 1, and with 18 we want it to be, the input would be 47. 56 would be the input for, when 18 and 47 is the input, 56 should be output. 57 should be output when. Okay, so this is what we want our inputs to look like. I put a snippet of code here. Let's say we indexed into data block size length of 2 sets from 0 and from 1. So this is our input is vector, and this is our output vector. So how we want to interpret this is, when 18 is input, 47 is output. When 1847 is input, 56 is output. When 1847 56 is input, 57 is output. And when 1847 56 57 is input, 58 is output. So basically we want to replicate something like this. Out of this array of 4 length, we want to make 4 different examples incrementally. So ideally we want to, so what is going on, let's see what is going on here in this loop is, we are iterating block size type number of times. Every time we are indexing into X for making our input, and we are indexing to take rather slicing to take from 0 till t plus 1 position, means till t time step, till current time step. And output is we are indexing into the tth position. So these two will be the input and output at any given instance out of the 0 till block size length. So we are printing input and output at each time step. Let's see what it prints. So you see here something similar to, let's say I remove this here. So when it is in 18 is input, 47 is output, which is same as this. When 1847 is input, 56 is output, right? So we are making same thing. So out of this one array of, out of this two arrays x and y of length 4, we make 4 different training examples with each of these of 4 elements and y as an input, as an output for each instance. So this is about the time dimension. Now let's say we want to maximize the best possible way of the GPUs, we want to add a batch dimension to it. So let's say we make a batch size equals to 2. Now here what we are going to do is, mm, 0 and, for this range from 0 in range 0 in length of data, we are generating indexes of size batch size. So we will generate 2 different indexes, batch size. So this is what ix would look like. It will be two integers. Now what we want to do is basically we want to index into data x equals to data I and I plus block size for I in ix. Okay, so there was a problem when we use torch.stack, the output of this data should be a tensor, torch tensor. So I went back and I wrapped this encode function into a torch.tensor method, and therefore now we are getting data as tensor type. So now when we stack examples of size, block size from I till I plus block size, which starts with these two indices. So we stack them along dimension 0, so which is basically row wise we are stacking the examples. So this we would get as x and x dot shape would be 2 by 4. So 2 is for batch size. There are two examples in this batch and 4 time steps in each example. So basically this is one example, one example, and this is the second example. Now let's break this up into the outputs and what it looks like. So now here we would also want to take toys dot. We would also want to make a wise, which would be which would start from I plus 1, go till I plus 1 plus block size for I in ix, and we wrap this in. We wrap this in dot stack. So print x y. All right. So here this is x and this is y. So for this input vector, outputs we can get from this vector, right? So now let's break them into this format, and we'll see what's going on. For b in batch size, b in block size. So ideally what we want is, if one example, one vector of length 4 is making 4 training examples, when we talk about in this manner, uh, of context window of length from 1 till 4. So 4 times 4, this should ideally make, this x and y should ideally make 8 training examples for us. So let's see. We take the bth batch, and block size we take as and the time step we take as as slicing from 0 till t. All right, 1 2 3 4 5 6 7 8. So we have 8 examples now. So you see these 4 examples are formed with starting examples from batch b plus 1 Okay, so from example one, which is this, we are starting to make the examples input and output. So when 53 is input, 56 is output. When 56, 53 and 56 are input, 42 would be output, and so forth. When this entire thing is input, the 58 should be output. So that's what we get here. And for next example, it will use the next element in this array to use inputs and outputs. So this is what our input and output would look like. And this would give us an input of, let's say, mm, okay, so basically this is what our examples would look like when they go into as into the transformers. And so let's now convert this into a function that would give us a batch of data. Before doing that, if we can convert our data, break or split our data into trains and well set your data into 0.9. Okay, so train equals to data till n equals to data from n. So this is a train and validation data. Whatever the split we give here, So depending on our split, we'll decide what our data is, and whatever it is, mm, let's say we call it as T. Depending on this, we'll decide our indexes of size, batch size, and once you have our indexes, we'll iterate for these many batches. So basically, we don't need to do any of this right now. All we want to do is we make a XP by stacking these trains for I and IX along dimension 0 and YBs along dimension. So this should plus 1 plus 1 plus block size, right? Plus block size. So once we have this, we return XP and YB. Print a batch from this for I and IX. Cool. You see, 2 by 4 is the size of the X and YBs, and this is how they look like. This is XB, which is 2 by 4, and YB. And we just saw before this how do these examples would look like actually. So now that we have this data, let's try to print this also. For B in range batch size, for T in block size, when input is XP of bth batch and index till T plus 1. Output is YP of bth batch and T index into T. Alright, so when these are the inputs, come on. When these are the inputs, these are the outputs. So 53 input, 1 is out, sorry, 56 is output, 53, 56 is input, 1 is output, and so on. So this first element in the batch gives us 4 examples. Second element in the batch gives us 4 different examples. So this basically would give us 8 training examples, training samples. All right, so we have a get batch function. Now we can move on to the next part.